Hello guys, today we're doing question 389, which is find the difference. It's an easy question. The question is, you are given two strings S and T. String T is generated by a random shuffling string S, by a random shuffling of string S, and then add one more letter at a random position. Return the letter that was added to T. Input S is equal to A, B, C, D. The T is equal to A, B, C, D, E. As you can see, it's shuffled. Well, it's not actually shuffled. They just added a letter at the end, but it would have been shuffled. You just can't see it. The output is E because E is the extra letter. Explanation: E is the letter that was added. So input example 2, S is equal to T, S is equal to MT, T is equal to Y. The output is Y because Y was added. So the way we're going to do this is, as the letters are shuffled, we will sort the strings in alphabetical order, and we'll loop through T as it's the longest string. And if we find a letter that does not match the letter at S when they're sorted in order, we'll know that that letter was added. And so we return that letter at the value, at the index, sorry. Let me show you how we do this in a whiteboard. Okay, as you can see here, we have S, which is our original string, A, B, C, D, and T is S, which is shuffled, and an added letter. So you can see A, B, C, D are in here, and we've added E. Excuse the bad writing on that T. And what we're going to do is we're first going to start by sorting the strings. So the way we do this with a string is splitting each letter, and then we sort them by alphabetical order and join them. So I'm not going to show the code here, but I'll just sort them for the sake of it. So S is already sorted. So T sorted would be A, B, then C, D, and then E. C, D, E. So now they're all sorted in alphabetical order. So what we do is we loop through T. So we'll do for each letter in T and S we compare at I value. So I is equal to 0 for now. And we compare the position in each letter. So is letter of 0 equal to, letter of 0 at S equal to letter 0 of T? Yes. So then we increment the I to 1. And we compare that. Is letter at value 1 the same? Yes. So we increment I again. Now that's 2. Is letter at value 2 the same? C? Yes. So we increment I again. So D. That's a letter 3, sorry, that which is D. Are they the same? Yes. So we increment again to 4. S doesn't have a 4, so there's nothing. And E is at value 4 T. Are they the same? No. So we return a 4th value at T, which is E. The reason we sort the string in alphabetical order, or the reason we sort the string, is because if we didn't, and when it was shuffled, for example, let's say it was A, B, C, D here, and B, C, D, A, E here, the first value would not match. And so we return B, but B is wrong because it does have B. That's why we sort it. So all the values will be the same up until the character that's changed, which is E. So let me show you how to do this in code. So first thing we do is we sort S and T. So S is equal to split. We split first for each string, for each letter. Then we sort it, and we join it back to a string. We do the same for T. Sorry, this is S.split. T is equal to T.split dot sort dot join. Then we loop through T. So for letter of, well, you know what, let's do for let I is equal to 0, because I is smaller than T.length, we increment I. The reason we loop through T again is because T is longer. So if you loop through S, if the last letter is E, if the last letter is the one that's different, then S won't figure it out because S is shorter, so it won't loop through the last letter. So we return we check if the letter at S, so Si, does not equal to Ti, then we return Ti, which is the index value in string T, so the letter that is different. And that should pass because, yeah, so let's submit, let's run first. Wrong answer, A, B, C, D, output. Okay, so what we'll do is we'll loop through S.length and we return Ti. Now, if the last letter is T, then it won't trigger in the for loop, so we have to return it. So return string T we notice the last letter if it's not been triggered. So t.length -1. This returns the letter at the last position of t. Let's run. As you can see, it passes. Let's submit. This is one of the fastest methods. Let me run again. So the time complexity for this is on log n, because on, we're looping through the string, worst case, and log n because we're sorting the strings here. So it'll be on log n, and the space complexity will be on, as we are creating new strings here of s and t and storing them as new values. Even though we're overwriting them, strings are immutable in JavaScript, so that's why. Thanks for watching.